Uh, Hello class, welcome to this class. Your teacher is Mr. Douglas, and want to take you through through physics, and the topic today is resistors. Stay tuned, and I hope you will enjoy this lesson. Come. Now, I've said that we want to talk about resistors. The subject is physics, and our subtopic is resistors. Now, class, last time you were taught about resistance, electrical resistance, whereby you were told that this is the opposition that a conductor offers to the flow of current. And here today we want to talk about resistors. Now, those materials that are actually designed so that they can be able to offer resistance to the flow of current. That is what we want to talk about here, so that we know the types of resistors that we have. Now, when we talk about resistors, class, we are saying that these are conductors that are designed to offer particular resistance to the flow of electric current. So resistors are conductors designed to offer a particular resistance to the flow of current, electric current. You know, they are conductors, of course, but they are designed in such a way that they offer specific or particular resistance to the flow of electric current. Now, these resistors are made of different materials, which include resistance wires. We have carbon and even metal alloys. So they are made of different materials. They are made of different materials, which include we have what you call metal alloys, carbon, and what we call resistance wires. So those are some of the materials that are used to make resistors. Resistors, which are the materials that offer a particular resistance to the flow of electric current. Now, we are also saying that most of these particular wires, most of the wire wound resistors are made of nichrome wire. We have got a nichrome wire, which is actually used to make most of the wire wound resistors. You know, it's a conductor itself. This nichrome wire is a conductor itself, but then it is made to offer resistance to the flow of current, a particular resistance to the flow of current. And these nichrome wires, most of the time, in most cases, it is covered with an insulating material, so that it can actually prevent the user from electric shock. Now, we want to talk about the types of resistors. In this case, types of resistors. We have got different types of resistors. Here we have got actually three main types of resistors. We have got fixed resistors, we have variable resistors, and nonlinear resistors. So one, we have fixed resistors, we have two variable resistors, and the three, we have nonlinear resistors. We call it nonlinear resistors. So these are the three main types of resistors that we have, and we want to discuss each one of these so that we know how each actually looks like and how it works to over a particular resistance to the flow of current. Now let's begin with fixed resistors. So the first one, fixed resistors. So when we talk about fixed resistors, as the name suggests, these are resistors that are designed so as to give fixed resistance. I'm saying that you cannot vary the resistance of this one. That the resistance that you set for this fixed resistors is the one that you will be using throughout in that particular conductor or in that particular circuit, and therefore they are designed to give fixed resistance. They are designed to give fixed resistance. Their resistance is actually fixed at a given value, and they are of different types. We will let us look at the different types of fixed resistors that we have. We have the wire wound resistor, we have got the carbon resistor. Those are the main types of fixed resistors that we have: wire wound resistors and carbon resistors. So e.g. wire wound resistors and carbon resistors. Now we can use a diagram to show these two types of fixed resistors that we have. The wire wound resistor will look like this. Okay. So that we have a wire now wound here very close to one each other. So this is the wire wound resistor. Wire wound resistor. So this is just but a wire that is wound around this one, and this one therefore is going to over a fixed resistance. So if you set, for example, if you set this particular wire wound resistor at a fixed resistance, let's say 10 ohms, that is the resistance that will be offered by this particular wire wound resistor throughout in that particular circuit. Yet we have another one that we call carbon resistor. Carbon resistor will appear like this. So this one has got some color bands. Color bands. This is what we call carbon resistor. Now, those are the two types of fixed resistors that we have. So for the carbon resistors, you can see it has got some color bands on it, and those color bands are on to over a certain resistance. So each color is designed to give a certain resistance for that carbon resistor. Now, the fixed resistor here can be a wire. We have said it can be a wire like this one here, and if it is a wire, then it is a nichrome wire. A nichrome wire which is wound around this one here, and we said that this nichrome wire must be insulated so that it can prevent the user from electric shock. So that's the first type of resistance that we have, fixed resistor, which is designed to give a fixed resistance to the flow of current. Now, another type of resistance that we have is variable resistors. Type number 2, variable resistors. Now, when we talk about variable resistors, as the name suggests, these ones now are designed in such a way that they can give a varied range of resistance. That means you can be able to vary the resistance on those particular resistors. So they are designed in such a way that they give a wide range of resistance. So they have a varied range of resistance. A wide range, so you can be able to vary that resistance from, let's say, 1 ohms to even 10 ohms. In between there, you can be able to vary that resistance, because that one has a wide range of resistance, like you have said, and they are of different types. Variable resistors are also of different types. This will include the rheostat. It can also include the potentiometer, the rheostat and the potentiometer. So we are saying that they include rheostat and potentiometer. Potentiometer, rheostat and potentiometer. Now, what about the rheostat? Because those are two examples of variable resistors that we have, the rheostat and the potentiometer. Now, let's briefly talk about the rheostat. Now, when we talk about a rheostat, this is a 2-terminal variable resistor. It is a 2-terminal variable resistor. It has got 2 terminals, so it is a 2-terminal variable resistor. It has got 2 terminals, a 2-terminal variable resistor. That is what we call the rheostat, and therefore it can take this particular shape. You can have it this way. So we have got one terminal here, another one here, and yet we have got this contact which is used now to vary the resistance of this rheostat. So we can have terminal A, terminal B here, so that your work is to slide. This is a contact that you can be able to slide along this length of this particular resistor rheostat, so that you vary the resistance. That is one of the symbols of variable resistor. Yet we have another one, we can also have another one like this. So you can see this one is a bit different from this one here. This one has got the two ends here. We have got terminal A and terminal B. Yet for the other one, we have got this. We have got this terminal here, terminal A, and this contact, which also forms another terminal on this other side here. But now for this one, you will be varying this contact. You know, this is a contact that is in contact with this resistor here, so you will be sliding it along the length of this resistor. Now what you need to understand is that when this particular contact is closer to terminal A, then the resistance of this resistor is very low, but as you move it away from A, resistance tends to increase. Same case to this one here. If this contact is very close to terminal A, then the resistance will be low, but as you move away from A towards B, resistance of that rheostat will actually increase. And so I'm saying that moving the sliding contact along the length of the resistant material varies the resistance between points A and B. That's what you need to understand. Moving the sliding contact along the length of the resistant material if you move this contact, this is a sliding contact, this one along this length of the sliding material will actually vary the resistance between the points A and B. So varies the resistance between points A and B. That's why I said that if the contact is closer to A, then the resistance of this resistor will be lower, and if it is closer to B, then it will be higher. So if the contact is nearer and A, then the resistance of the rheostat is lower. So as the length increases from A towards B, resistance also increases, and that's how you can be able to vary the resistance of this variable resistor, which is the rheostat. Now in most cases you will find this variable resistor, the rheostats, used as knobs on radios. Those volume control knobs on radios, they are essentially rheostats. Those ones that you use in varying the volume of radios, that knob is basically a rheostat. Now, part 2, we want to talk about the potentiometer also under the variable resistors. So that we also know how it looks like potentiometer. Now, this one, unlike the rheostat, which has got only 2 terminals, this potentiometer has 3 terminals. So it is a variable resistor, yes, but with 3 terminals. So it is a variable resistor with 3 terminals. It has got 3 terminals, unlike the rheostat there, and it therefore looks like this. It therefore looks like that. It has got 3 terminals. We have got terminal A, terminal B, and terminal C. In this case, terminal C happens to be the contact, the sliding contact. So we can be able to slide this terminal C from, maybe we can be able to move it from this end to nearer end A, and or away from A towards B. So we say that in this case, still when the contact, this is a contact, the terminal C is a contact, sliding contact. When it is nearer terminal A, then the resistance is very low. But when you move, as you slide it now towards end B, resistance will actually increase. So a contact is moved to select desired proportions of the total voltage. That these potentiometers with, of course, a circular resistance tracks are used as a balance control in audio amplifiers. Those potentiometers with circular resistant tracks will be used as balance controls in audio amplifiers. They are used to balance the sound in amplifiers. That is what we have in potentiometer. Now, number 3 type of resistors that we have is nonlinear resistors. Nonlinear resistors. Nonlinear resistors. So in this case, as we are talking about nonlinear resistors, you know, for the two here, for the variable resistors, for the variable resistor, we say that if, for example, you have a graph of voltage against current, so if current actually is higher, if the voltage is higher, the current will also be higher. So as you increase, as you reduce the resistance in these particular resistors here, as you reduce the resistance, so that is to move this sliding contact to nearer end A, then more current will be flowing. As more current flows, it means that the voltage is also higher, so they can be the current and voltage will be directly proportional. But now when you talk about nonlinear resistors here, the increase in current does not linearly increase linearly with the voltage. So that means that as the resistors increases, current flowing will actually vary from one point to another. So current flowing through these resistors does not change linearly with the change in the applied voltage. The change current flowing through these resistors does not change linearly with the applied voltage. The current flowing through these resistors will not change linearly with the applied voltage. That means that you may increase current, but voltage actually decreases, and so we are going to have a nonlinear kind of graph. So that is why we are calling it nonlinear resistor. Now, such resistors now will include the thermistor and light dependent resistors. So they include the thermistor and light dependent resistors, LDR in short. Those are the two types or two examples of nonlinear resistors: the thermistor and light dependent resistors. That is what we have. Now let us also look at the thermistor so that we understand how it works and how it looks like. Thermistor. Now, a thermistor here is from the word thermal, and therefore thermal means here temperature or heat. So this is a temperature dependent resistor. It is a temperature dependent resistor, that it depends on temperature on its operation. It depends on temperature on its operation. Now its resistance will decrease with increase in temperature. That's another thing that you need to know. Its resistance decreases with increase in temperature. It means that as temperature for these resistors, thermistor resistor increases, resistance, as the temperature increases, the resistance for that particular resistor will decrease. So they are nonlinear. As temperature is increasing, the resistance will be decreasing. That is what you need to know. And therefore, we can use this particular symbol to demonstrate this thermistor. It looks like this. So we have got these terminals there and this end. Then we have this one. That is the symbol for a thermistor. This is the symbol for a thermistor. It looks like that. And don't confuse this one with the rheostat. As you can see, the rheostat here, it is just like this one, but this one has an R at this end. But this one here for the thermistor, the sliding contact here is like a Z kind of, and therefore this one will give us the symbol for a thermistor. And these are the terminals for this thermistor as a resistor. Now, these thermistors, in most cases, they are used in heat-operated circuits because it is a temperature-dependent resistor. Therefore, it is used in heat-operated circuits. So, you can also note that particular point that thermistors are used in heat operated circuits. Heat operated circuits, that's what you need to know. That means if the heat, for example, in a given circuit increases, resistance is going to decrease. That is what you have said. If the heat for a given circuit increases, then resistance is going to decrease. So the higher the temperature, the lower the resistance for these thermistor resistors. That is what we have. Now another example of nonlinear resistors that we talked about is light dependent resistors. Part B, light dependent resistors. In short, it is called LDR, light dependent resistors. So for this one, as the name suggests, these ones are going to depend on light for their operation. They depend on light for their operation. So it's for this one here. Now resistance is going to decrease when the intensity of light for this resistance increases. If the intensity of light increases, resistance is going to decrease. So the resistance decreases when it receives light of increasing intensity. It is resistance decreases when it receives light of increasing intensity. That if light is too high, the intensity of light is higher, then resistance decreases. When the intensity of light, that's what? Increases. When light of increasing intensity, when the intensity of light increases, the resistance for these light dependent resistors actually decreases. That is what we are saying there. So the higher the light intensity, the lower the resistance for this LDR, the light dependent resistors. And this one is going to have this particular symbol here. It looks like this. We may have something like that, and then we have the terminals here. Then we direct the light radiations onto it like this. So as light comes, this is just but an envelope, a glass envelope that is transparent, that can allow light to penetrate and get into this particular resistor in here. Once it gets in here, then it is going to sense this intensity of light from this side, and once that light intensity falls on this resistor, the resistance is going to decrease. That means now light is going to, current now can be able to flow. Current can be able to flow, and when current flows now in that circuit, maybe that current now can be used to operate other circuits like the alarms, So you will find that in most cases, this kind of resistors, the light independent resistors, are normally located near doors or even gates, so that when you open the door or the window, light is able to come and penetrate into this resistor. Once this resistor receives that light, then current will flow and make the alarm to actually ring, and that one can be like a signal, signaling the people in there that maybe somebody has come in or the door has been opened. So that is the light dependent resistor, and we are saying that LB are used in light operated switching circuits. LDR are used in light operated switching circuits. LDR are used in light operated switching circuits. So class, those are the types of resistors that we have. The three of them: the fixed resistor, the variable resistor, and the nonlinear resistors. That is what we have in that particular case. So having talked about that, we can now look at measurement of resistance. We can now talk about measurement of resistance. So because of I would like to stop at that point because of time. Maybe that one we will discuss it in our next class, in our next lesson. But get to understand that for now we have talked about resistors. We have said that resistors are conductors that are designed to give a particular resistance to the flow of current. Again, we have said that we have got three types of resistors: the fixed resistor, we have got the variable resistor, and the non-linear resistors. Of course, the fixed resistor is designed to give a fixed resistance, like we have talked about. The variable resistors, they are designed to give a wide range of resistance. And examples of variable resistors we have mentioned, we have talked about rheostats and potentiometers. The rheostats have got two terminals, like we have said. The potentiometers have three terminals, and we have said that they have got what we call a sliding contact, so that when you slide that contact along the length of the resistor, you are going to vary the resistance. Yet we have also talked about nonlinear resistors. Under this one, we have said that the current flowing through these resistors does not vary, does not change linearly with the change in the applied voltage, and they will include the thermistors and the light dependent resistors. The thermistors will depend on temperature. They are temperature dependent resistors, and therefore, as temperature for a thermistor increases, resistance decreases. That is what we have said. As we increase the temperature, as the temperature of for this particular resistance increases, the thermistor's resistance will decrease. Now, for the light dependent resistor, we are saying that those are now light dependent resistors. They depend on light. For their resistance will decrease, meaning that, when you talk about resistance class, you need to understand that resistance is the opposition over the flow of current. And so if light falls on this resistor here, the light of high intensity falls on this resistor, resistance will decrease, and therefore more current will flow. As that current flows, now current will flow in the particular circuit, now actually to operate other systems like the alarms and all of that. So class, that is what we have talked about today. We'll read more about this one in our next class. We shall pick it up from there. Thank you for watching. Stay tuned next time. We'll proceed from there. Thank you.